Hi everyone, my name is Van. I worked on the suspension components for this year. So the goals for this year was to lose 1 pound with a high goal of 1.6 pounds. And for our compliances, we determined goals of 0.3 degrees of camber compliance and 0.03 degrees of max tow compliance. These were comparable from last year, just about, I'd say about 15% a decrease from last year's compliance numbers. And then for design changes, we want to explore a custom three-lug wheel sensor, reducing the mass of the uprights, both front and rear, and integrating wheel speed sensor mounts for the uprights. So here is a comparison between the 2018-2019 front uprights. I know it's a little hard to see based on the lighting projector. After running the FEAs, I did identical loading conditions for the bearing loads. These bearing loads were pulled off of 2018's bearing load calculator from what a previous team member had used. Oh, what?
Right? Yeah.
They're really a method of comparison. Yeah. As you can see, the factory safety for 2018 was around 1.17, and for 2019, 1.19. Comparably very similar. The calculations that were used for the bearing loads here were based off of different load scenarios. The two in here are based off of the autocross worst case scenario, where I pulled acceleration G-forces from autocross and then compiled them together in longitudinal, lateral, and bump loading. So this is the peak loading you would see in any scenario during autocross. In addition to that, I also have load cases for purely longitudinal, purely lateral, purely bump to explore just singular unidirectional load cases for the most extreme scenario. After doing the main change with the 2019 uprights was the cutouts, mainly just exploring weight loss and weight savings. So with that, we saw about half a pound of loss from the uprights in total, that's front and rear included. So around for all four corners, half a pound loss. Using, like I said earlier, we're using data from 2018 comp in Lincoln, taking data from our data collection for the acceleration forces from 2018 Lincoln competition, and then applying 2019 expected loads. Some of the main changes were, the main change was aerodynamics, since we're expecting, instead of last year, they calculated expected aerodynamic downforce to be about 400 pounds. This year we're expecting around 600, so that was accounted for as well in the loading case, loading scenarios. And then currently, I'm investigating fatigue failure. The factory safety numbers you see here are fatigue failure factory safety, not yield. So these are much lower than what you would see in yield factory safety. For yield factory safety, they were upwards of 2. 2 factor safety, which I deem pretty acceptable. But as of right now, for fatigue failure, I'm going to have to go back and revisit some of the designs and how I cut out the weight in order to raise that factory safety line. And I'll also have to explore more into the 2018 model and verify that those loads are valid to make sure that these factory safety numbers aren't just way off the ballpark. And then in addition to the front, these are the rears, which experienced about a 1 factor safety, which is definitely not where we want to be at. So again, I'd have to go back and revisit some of these load calculations in the calculator to verify if this is correct. But this gives me a pretty good ballpark of the changes of stress flow between both designs from 2018 to 2019. For the custom wheel centers this year, the step-by-step process is we used Altair's Inspire solid thinking software. I loaded a template, a wheel center template with the basic dimensions of the lug studs and the mounting bolts to the rim itself. Ran a topology optimization for considering maximum stiffness, and then using 30% of the design space volume. After running that, and the loads that were applied were, I constrained the lug nuts or the lug bolt bores, and then applied a torque on the wheel centers. That torque was derived from a basic hand calculation of the forces seen from braking, since that is the most force that we'll see for these wheel centers in terms of rotational torque. And then after pulling that model from Altair Inspire, that was then generated in SolidWorks, in which I performed two different kinds of load cases, braking and turning loads. So braking, like I explained earlier, was just a fixed center and applying a torque on the wheel rim mounting bolts. And then the corning load cases was taking it was basically a weight or a load transfer derivation, taking the maximum or the weight of the car and its approximated amount of G's in cornering, which we approximated to be 2 G's, and then applying it to one corner, and then the load applied on the wheel center was basically kind of a bending in plane. So taking one third, and in this case it was 1/3 of the wheel center and applying it in axis force. FEAs from that show of 2.4 versus 2.5, comparing it to last year's. Both I loaded both the generated custom wheel centers and then the Kaizers that we used in 2018, and then compared them. In comparison, factor safety of the custom wheel centers for 2019 are slightly higher, but in the same ballpark, while losing 0.9 pounds, or not losing 0.9 pounds. They weigh 0.9 pounds versus 1.1 pounds from 2018. Yeah. Are there any questions? Dr. Strobel?
Science looks great. However, have you ever thought about how much extra machine time you have to invest for the minuscule weight savings that you?
Yes. So I actually just this week talked to Nick from the machine shop, asking him what his advice was on machining these uprights. He said that the setup time should be minimal because the orientation necessary to make those cutouts are all in plane. So it should take one setup to make all the cutouts necessary. In order to manufacture or to make cuts to the caliper mounting and getting the profiles right, that should already be part of the setup. There shouldn't be too much extra dead time to CNCing the uprights. I also have two, that's also my backup plan, because right now, how the uprights are designed, they're not in plane. I have two, sorry, I should back up. I have two versions of the uprights. One have in-plane cutouts and one have cutouts that are more, I guess, perpendicular to the surface of it. Right now I'm working with Branson on getting a 5-axis mill company, or a company with a 5-axis mill to sponsor us to perform those cutouts. So in the case that doesn't happen, then we have another version of the uprights to fall back on, and manufacturing that should not be a problem.
My concern is just that you're getting minimal weight gains for a large amount of extra.
Well, we can definitely consider that. I'll make sure to double check with Nick as well as Jason from the machine shop to estimate the tool path and runtime for the CNC operation to see how much longer that would take by going with the new design. Yeah.
Two little notes. The little shafts you have that like connect them, that would all be like